Dear students, welcome to you all in WB e-learning system. I am Muhammad Tanbir Ahmed, lecturer, Department of Civil Engineering, World University of Bangladesh. Today, we are going to start a new lecture. Already you have seen the course title. The subject we will study today is Irrigation and Flood Control Sessional, which course code is C1006. This is a sessional course with 1.5 credit hours. Rationale. Actually, this is the fundamental principle of this course. This course aims to introduce knowledge and calculation about the soil section, bulk density of soil, infiltration, canal seepage, abstraction from aquifer, types of aquifer, irrigation scheduling, branch canal designing, and hydrograph analysis. At the end of this course, or after finishing this course, you students will be familiar about the said items or stated items. Outcomes. This course has the following two outcomes. That means at the end of this course, you students will be able to know outcome number 1, fundamentals of irrigation and equipment involved in irrigation. That means you can understand about the irrigation, factors affecting irrigation, soil and water quality and requirement in quality irrigation, and also the equipment used in irrigation system. Then outcome number 2, design, analysis and calculation in irrigation. That means you can design a branch canal for irrigation purpose, analysis, flood or hydrograph, and also to calculate the moisture content, bulk density, etc. So these two are the outcomes of this course. Outline of the course. These are the course outline or course content which we will cover in this semester. There are 9 content or outline we can see, and probably we will cover each topic per week. Outline of the lecture. Soil and water, two are the most important elements for irrigation, and in today's lecture we will discuss about soil-water relationship and soil properties. First, we will introduce about the mission and vision of the university and also the department. World University of Bangladesh is a renowned private university which has established in the year of 2003. Our Vice Chancellor is Professor Dr. Abdul Mannan Chowdhury sir. Proud to say that he is a freedom fighter and a former selection grade professor of the University of Dhaka. Vision of World University of Bangladesh. The vision of the university is to create leaders who will have enormous contribution to economic emancipation and social well-being of the country using his or her brain. This is really very great. Mission of World University of Bangladesh. The mission of the university is to become a university with quality and distinction, enabling students not only to flourish academically but also personally and socially. And the most important point is through utilitarian education with an affordable cost. And to achieve this vision, the university are continually being updated and improved to reflect the latest development in engineering educational area. Vision of Civil Engineering Department. The vision of the Civil Engineering Department is to be an internationally renowned department that will create leaders of the leaders who will contribute the economic emancipation and the national development of civil engineering field. Mission of Civil Engineering Department. The mission of the Civil Engineering Department is to advance engineering knowledge and learning to fulfill the aspiration of the university and the nation through utilitarian education and research. Irrigation. First, let's introduce about irrigation. Irrigation may be defined as the science of artificial application of water to land in accordance with the crop requirements throughout the crop period for full-fledged nourishment of the crops. We know without water, plant cannot live. So when land becomes dry, to keep the soil moisture in a favorable condition, water is added to land or crops, which is called irrigation. Here we can see two pictures, and these two pictures belongs to irrigation. Here, this picture shows the irrigation which is done by sprinkler irrigation method, and this method is called furrow irrigation method. And you have introduced about all these irrigation methods while studying the theoretical course of irrigation and flood control. Now, importance of irrigation. Irrigation is very important for crop production. The major importance or advantages of irrigation are as follows. Number one, it increases in food production. Obviously, it increases the food production. If we don't provide sufficient water to crop, the production of food will decrease. Importance of irrigation. Then it is the point number 2. Irrigation adds water to soil, which increases the essential moisture content and makes soil favorable for plant growth. To provide crop insurance against short duration droughts. It is as like as insurance. If we can cultivate more crops, it can save us during droughts. So we can say it is like as an insurance. Then number 3, to cool the soil and the atmosphere, thereby making more favorable environment for plant growth. To reduce the hazard of frost. As we know, water makes the soil soft, so it can reduces the frost action. To wash out or dilute salts in the soil. We know salt water is not favorable for plant growth, and irrigation can effectively remove the salt. Then the last one is to soften tillage pans and clods, as water always make the soil soft, so it can easily happen. Basic soil-water relations. It is very much important to have the knowledge about the soil-water relations if we want to obtain the best use of water. The soil-water relations include well-drained soils in the field, which can drain water into the interconnecting voids of soils, and also to retain water available for plant growth. Then the salinity and alkali conditions. Water may contain salts or it may be alkaline. So it is very much important to know the limits of saline or alkali for different soil and for different plant. Then the last one is evaporation of soil water. Water may evaporate from soil, which differs with the soil types. It is also important to know the quantity of water and interval of irrigation. The soil-water relations depends on the following properties of soil. So these are the soil properties. First on soil texture, soil structure, real specific gravity, apparent specific gravity. We will discuss all these properties from the next slide. These all are the properties of soil, and we will discuss all these properties from this slide in this lecture. Soil texture. This is the first properties of soil. The soil particle size determines the soil texture. That means we will get the idea of soil textures from the particle size of soil. And these particle sizes ranges from fine gravel to clay. If the particle size is greater than 1 mm in diameter, we will name the soil as gravel. And if the particle size ranges from 0.05 to 1 mm in diameter, then we will name the types of soil as sand. Similarly, particles ranges from 0.002 to 0.05 millimeter in diameter, termed as sealed, and if the soil particles less than 0.002 millimeter in diameter, then this will be termed as clay soil. Most of the soil contains a mixture of sand, silt and clay, and if in mixture the percentage of sand is greater, then the sand particles will dominate and the type of soil will be called as sandy soil, or the soil is called sand. Similarly, if in the mixture the percentage of clay particle is greater, the clay particles will dominate and the soil will be called as clay soil. Seeds fall in between clay and sands. That means it will be smaller than sand but greater than clay. Here we can clear to see the dimensions of silt particle, which is greater than clay but smaller than sand. Loams are medium texture soils having about equal amounts of clay, silt and sand particles. That means in soil, if silt, clay and sand particles are in equal proportion, we will call the soil as loam. Soil structure. Soil structure depends on the atomic bond of soil particle. And to maintain and improve the structure of irrigated soil, the following can be done. Number 1. Plow below compacted layer not at the same depth each year. If we do this, the vitamins and minerals of different layer will be used and there will be a balanced nutrition in each layer. Then, allow as much time for soil and air to interact before preparing seedbed, which will return all possible organic matter to soil. If we can do this, the soil can absorb oxygen and will try to regain its original states. Number 3 is follow a good crop rotation on legumes, cash crops and fibrous rooted crops. As we know, each crop needs some certain minerals from soils. So, if we cultivate same crops every year, there will be a shortage of certain minerals from soil. And the last one is, if possible, reduce cultivation and tillage operations to a minimum so that soil gets sufficient time to regain its original state. Real specific gravity. Real specific gravity is the ratio between the density of a single soil particle to the density of volume of water, and this is unitless. That means this has no unit, as this is the ratio. The specific gravity of common soil forming minerals varies from 2.5 to 5, and the real specific gravity of soil is 2.65 if the soil have low percentage of organic matter, and if soil have largely of organic matter, its real specific gravity may be from 1.5 to 2. Apparent specific gravity. It is the ratio between the weight of a given volume of dry soil, including air space, to the weight of an equal volume of water. This is also the dimensionless. That means real apparent specific gravity also not have any unit. Infiltration. It is a soil property and has importance in irrigation. Generally, we can say infiltration is the entry of water into the soil. More precisely, it can be say that it is the time rate at which water will percolate into soil. It is also called rate of infiltration. Generally, the rate of infiltration is higher at the beginning of rain than few hours later. As the soil gets saturated, sometimes after the rainfall. Permeability. Permeability is the property of soil which permits the passage or entry of water into the soil through its interconnecting voids. Hence, permeability is the velocity and can be expressed as physical dimensions of length divided by time. Permeability is influenced by the following factors. Number one, physical properties of soil. If the soil has much more interconnecting voids, the permeability will be greater, otherwise it will be lower. The changes in water temperature. As we know, the temperate water can percolate largely or percolates greatly into the interconnecting voids of soil. Then permeability varies between wide limits 25 cm per year compact in case of compact clay soil. That means this 25 cm is the variation of permeability, may be greater or may be lower. Soil moisture content. That means the moisture or water present in a specific soil. The soil moisture content can be calculated using this equation, and this is generally dry wet basis. So soil moisture content on the dry wet basis, Pw, if we indicated this as Pw, we will get loss of weight of soil in drying divided by water free soil. Loss of weight of soil in drying. That means this is actually the amount of moisture or water, because in soil, if we dry the soil, the only loss will be the amount of water. So this is the amount of or weight of water, and this is weight of water free soil. That means this is the weight of dry soil. And normally moisture content is expressed as percentage. So if we want to express this as percentage, we will multiply this ratio with 100. And there is the example. Let's read the question. Weight of moist soil 100 gram. Weight of water free soil equal to 80 gram. That means this is the dry weight of soil. We have to estimate soil moisture content for these two conditions. Number one, dry wet basis, and number two, wet basis. Let's try to solve this question. First, here loss of weight in drying equal to 100 minus 80 equal to 20 gram. Actually, this is the moist weight. That means this weight includes weight of water and weight of soil, and this is water free soil. That means after drying weight stands 80 gram. So what is the loss amount? Loss amount is 100 gram minus 80 gram equal to 20 gram. Actually, this loss amount is the weight of water or moisture. Our first question was dry wet basis. So we know dry wet basis moisture content is loss of weight of soil in drying divided by water free soil. Now loss of weight of soil in drying equal to 20 gram we have calculated here, and weight of water free soil equal to weight of water free soil equal to 80 gram. And to calculate this or to express this moisture content as percentage, we have multiplied with 100. So moisture content in dry wet basis is 25%. Similarly, we have to calculate the moisture content for wet basis. Soil moisture content on wet basis, P equal to loss of weight of soil in drying and divided by weight of moist soil. Here in dry soil weight of water, it was weight of water free soil, and in wet basis it will be weight of moist soil. So loss of weight of soil in drying is 20 as same as number 1, and weight of moist soil, here stated in question weight of moist soil is 100 gram. So this is 100, and this 100 is to express the moisture content is percentage. So we will get moisture content on weight to weight basis equal to 20%. That is the end of our today's lecture. Thank you everyone.